Hello, welcome to Math with Mrs. Matson. Today we are going to be solving one-step equations using addition and subtraction. We talked about in our previous lessons how we can think of equations as like a balance. So if we have x plus 6 on one side and equals 9 on the other side, to figure out what x is, we can take away the exact same amount and still have a balanced equation, so still being able to use that equal sign. But now we have x by itself, and we know that that is equal to 1, 2, 3 on the other side. So that's what we've modeled and we've seen. Today we're going to kind of go beyond the model and just look at equations algebraically and just solve them with the equation in front of us, not using a balance. What we need to remember, though, is that we are going to use inverse operations to isolate the variable and figure out the value of that unknown. So everything we do today, if we do it to one side of the equation, we're going to do the exact same thing to the other side of the equations. And most of these equations you'll be able to figure out mentally. You'll be like, oh, well, x is 27 or x is 2, right? So that's not really the main point today. The main point is not to figure out what x is. The main point is to kind of show and model what's going on using inverse operations, so that in 7th grade, when the equations get longer and scarier looking, then we've got that practice down of if we do it to one side, we're going to do it to the other. So that's my big focus today. That's a big thing I'm looking for today, is showing your work and showing how you are using inverse operations. So what I want you to do on this is isolate the variable to find the value of the unknown. The x right there is our unknown. Okay, now we can look at it and be like, well, x has to be 11, right, in order to make this equation true. What I want to see, because I already know you know the answer is x. So the practice today is showing what you're doing in your head. Okay, so what you're doing in your head is going, okay, well, if this is a minus 7, then I know I need to plus 7 to 4 to get 11, right? So this is how I want it to look. I want it, if it's minus 7 on top, I want us to do a plus 7. Why? Because that will give me 0, right? If I'm at negative 7 and I add 7, I'm at 0. And so what I have now is x plus 0, which is just x, isn't it? And I have now isolated the variable. Okay, but guess what? I've now added 7 to this side of the balance. So now I'm tipped. So I've got to keep it so I can have that equal sign and sign. Well, if I'm going to keep it equal, then I need to plus 7 on this side. And this is how it will look. And so that's how I get that 11. So yes, x equals 11, but today I'm looking for this work so that I can see that you can visualize what's happening to each side of that balance. Okay, now if we have a question like this where x plus 6 equals 12, my goal is to isolate this variable, get it by itself so that I know that x equals down at the bottom, right? Well, I have a plus 6 right here. What's the opposite of plus 6, or what's the inverse? The inverse is the opposite, and the inverse of plus 6 is a negative 6. And if I have 6 minus 6, that gives me 0, right? But instead of putting 0, I often just like to do this. I often like to whoosh, and now that's gone. And the only thing I'm left with now is the variable. So I took 6 away from this side of the balance. So now I'm tipping this way. What do I have to do to the other side to get it balanced? I have to do the exact same thing. I need to now minus 6 on this side. So both sides of this equation are now back to being balanced because I did the exact same thing on each side. Oh my gosh. Oh, guys, I thought I didn't push play. I thought I'd have to start over. I did push play. I'm 4 minutes in. Okay, let's keep going. 12 minus 6 equals 6. Okay, and if we want, we can plug it in. And where it says 6 plus 6 equals 12, well, I now know what 6 is. Let's see if it actually is a solution. What is 6 plus 6? Shocker, it's 12. So I did do the inverse operation correctly. Okay, so those were two very simple problems that you could do mentally. But we can also do these type of problems with fractions and decimals, and we're going to do them the exact same way. We see here that here's our f, here's our variable, our unknown that we want to isolate, which means we need to get rid of this 2/5. Now, how can we get rid of a 2/5? Well, we need to use inverse operation, right? But how do you know if that's a positive or a negative 2/5? There's nothing in front of it that says it's a positive or a negative. Yes, exactly. You know that there is an invisible positive sign there. If a number is negative, there will be the negative sign in front, no matter what. But we're often lazy and we often don't put that positive sign in front of every single number. So it is positive, which means that the inverse of that is subtraction. So we're going to subtract 2/5. And why are we going to subtract? Why are we going to use the inverse? Because that means that it cancels out. There's now nothing on the side of the variable except for the variable. We have successfully isolated the variable. But if we're going to take 2/5 away from that side, we need to do the exact same on the other side to keep these equations balanced. So let's minus 2/5 here. 3/5 minus 2/5 is 1/5. And I can plug it back in to see. Instead of the f, I'm going to put 1/5. Is it true that 2/5 plus 1/5 is 3/5, like it says right here? Yes. So we've checked it. We are 100% certain that we know that f equals 1/5. Okay, so using inverse operations work even if the equation has fractions and decimals. And with this decimal problem, we have m minus 25/100 equals 42/100. So for this, in order to isolate the m, we need to get rid of a minus 25/100 or a negative 25/100. Either way you look at it, it's the same thing. Minus 25, negative 25. How do we get rid of a negative 25? Well, we do a positive 25/100. And those two will cancel out, leaving me with just m. And then if I'm going to add 25/100 to one side, I have to add 25/100 to the other side to keep it balanced. So I'm going to show that adding 25/100 on this side as well. And that will give me 7 and 6.0. So my answer is 67/100. Now in your notes, if all you have is m equals 67/100, you're not doing the practice that you need to be doing. I need to see that you're doing the inverse operation, and I need to see that you're doing the same thing to both sides. Those are the two things I'm looking for. If you then want to test it out and see if it really is a true statement, a true equation, a solution of the equation, then you can do this work right here, which is checking for your work. Okay, so make sure you have those things. That's the real practice of today. All right, this one's a challenge. This one's tricky. I want to see if you haven't had your brain stretched yet, I want you to stretch your brain on this problem. Pause it, and I want to see what you can do to figure out what x is in this expression. Because what I would think you'd do is you'd be like, okay, well, minus 35, that will cancel out. But then look what I have, 16 minus 35. And then my x isn't really isolated because it's a negative x. And this would put me in the negatives, wouldn't it? So this one's kind of a tricky problem. I don't know if this is really a 6th grade problem or more like a 7th or 8th grade problem. Probably more 7th grade. But what would we do? Here's what you could do. You could plus, instead of adding a number, we can actually add an x. That would cancel those out, leaving you a 35 over here. And on this side, those aren't like terms, are they? So we would be left with 16 plus x. Okay, now let's see if we can isolate the variable by subtracting 16 on each side. That will cancel out, leaving us with just the variable. And then 35 minus 16 is 19. Okay, but again, that was like a 7th grade equation that I just wanted to see if some of you could figure out. So no worries if you're like, what the heck just happened? Moving on. This is something you can do though. If I say x equals 9, what could your equation be? I'm going to have you kind of work backwards. Okay. Oh, gosh, what could you do? X plus 1 equals 10, right? Let's see if that would work, because then we need to minus 1 and minus 1. X would give us 9. So that would work. What if we did like a subtraction problem? X minus 7 equals 2. Would that work? Because then we would need to isolate the x by adding 7. Yeah, that would work. That whoop is gone, leaving with x equals 9. So there are lots of different equations you can make. Okay, this is not something you're going to be using on your homework, but just something for fun. So what you've worked on today is using inverse operations to isolate the variable, get the variable by itself, and then solve to find the unknown variable, unknown value of the variable. Okay, so here's what I'm going to have you do on your own. What's the unknown variable? I didn't even give you instructions. Solve for b. What is the value of b? Well, I want to isolate b, get b by itself, so I'm going to add this 2/3 because this is a minus 2/3. So I'm going to get rid of it by doing the inverse, by doing the opposite. But if I'm going to add 2/3 over here, that means I need to add 2/3 over here as well. And that would give me 1/3 plus 2/3 would give me 3/3. And then 2 and 3/3 is just the same thing as 1, right? So it actually a total of 3. 3 equals B. Did you get it? Okay, awesome. All right. Now, oh, this is with your partner. Yeah, sorry, I want you to do this on your own. Select the equations that have the solution n equals 23. Mark all that apply. So there might be 4, 1, 2 actual solutions. Okay. I'm going to say, let's do minus 16 minus 16. Swoop. Then we get, ooh, that's 23. So A works. This is a minus 4. So I'm going to add 4. Swoop. Get rid of that. And that leaves me with 23. That works too. This is a minus 2. So I'm going to plus 2. That leaves me, oh, that one left me with 27 equals n. So not C. And then this is a minus 11, so I'm going to add 11. And that gives me 23 equals n as well. So there's 3 of them that are correct. How well did you do? I was just thinking I was doing this. One of the biggest mistakes that I see people make is they don't know which one to subtract. And what you need to remember is you are getting the variable by itself. So whatever is by the variable is what you're doing the opposite of to get rid of. Okay? Get some practice in, get that trail paved. You'll be ready for the mastery check. Plus, you'll be ready for 7th grade because you do this all throughout 7th and 8th in high school. So really, this is really important for you to know. See ya.